you have it done already completed before, and you have information showed to you. Like this example, when I'm clicking the Explore button, okay. Now I'm actually now jumping a little bit because I'm started the Fusion software, but still, like I said, this is the second part of my explanation with the foundation of two things before we get into the topics of generative design, right? Foundation number one, behind the scenes, is Fusion team. Foundation number two, Fusion 360 is beyond just normal CAD and CAM, right? So I just show you that how you can use the model part of this to do a lot of modeling. And now this is the, before when you get into the outcome of different AI giving you the result. See, I'm using this notebook, very thin notebook. It is humanly impossible, or even the notebook itself is impossible to generate one of this model. If I'm going to use this computer to generate one of this chef, right? One of these chefs, it may take me days or weeks. You need definitely workstations, right? Because to the calculation. But AI, because when we do the setting up, right? Before I get into the Explore, if I say finish in Explore, I'm doing the setting up, right? So in the setting up environment, you go through all these steps here, right? And then you just solve the problem. When you solve the problem, this is thanks for yourself. If I'm going to do this and say I want to solve the problem, right? So, and the moment I say I want to solve the problem, this is where if you say how many credits or cloud credits you will consume, and then typically one of these problems you take 25 credits, and although it reduced 25 credits from the account, if you have 30 days trial, there's no limits of how many credits, right? I mean, 30 days trial, if like right now you have access of Fusion 360, but you do not have the access to solve in this manner of generate. When you do generate, then you have the result, okay? So when you're doing the generation, it's actually cloud computing, AI, artificial intelligence, and doing the calculation for you. And that example I was showing you earlier on with this setting, and then coming up with the result of maybe about 50 kind of a result, and then it typically takes 1 hour. I mean, like this, I remember it's like 1 hour, all right? And so once you have the model that you have selected, right? Like example, now I'm getting into the model, and I have selected the model of my choice based on what are the decisions criteria. Now the decisions criteria are based on, you can see on the left hand side. So I'm still in the topics of generative design. I'm actually more on the hands-on explanation of the functionality of a generative design. I'll come back into like the overview pictures and everything, right? So you will have the criteria you're selecting, and it's based on the criteria you're selecting, you come up with a model. So it's a real AI, and a real CAD, because what's happening, right? It's based on the criteria additive manufacturing. So you know what is additive manufacturing for 3D printer, and it's metal. And you have the choice before I do analyze, I will say, okay, how many type of material you want to choose? You can do special type of titanium, aluminum, plastic, or special whatever. So when you put a few criteria, and then you want to reduce, the mesh, all right, or how heavy you want to make it very much lighter, your objective, and yet at the same time you want it to fit within the safety factor, right? So therefore, then sometimes the pictures like this is making it very difficult for you to make decisions, right? So you can choose like showing a form of a graph. Okay, so the graph, as I hovering around, right, this choice of my decisions, right, so you can see it's actually updating on the pictures. So it's basically, the graph will help you to make a more refined decisions after you giving the decisions criteria for the AI to do the calculation. Okay, so although I'm jumping a bit with the generative design, I already explained again. So this is where the functionalities of what you call all-in-one. I mean, you know, all-in-one printer, right? 3D printer, I mean, the normal printer now, in the past, just do printing. Then you can do scanning, you can do printing, you can do fax, whatever you want, you know. Now I call it all-in-one cloud tool, you know. In the past, when we have first version of Generative Design, it's still not all-in-one because it's a separate software you need to install. And that was like last year. So somewhere end of last year, then we have, you know, a year ago more than that, you know, then we have it integrated. So the emphasis is very much in all the tools that you want in the integrated environment. Because it's an integrated environment, it's make it very friendly and very easy for you to move forwards. And it's very inspirable, you know, inspiration, because you can, you know, based on this to do a lot more. Now, the next thing which is very important for you to understand about the Fusion software is this thing called history, right? Let me just highlight to you underneath that, right? So this is the history being captured. As you model, and I mean, just like any desktop you can, right? They call it browser, okay? The model tree or whatever, you know. So, you know, the browser itself will show you the history of the features and all these things. Similarly, this is also having it. So now, if I go back into this model here, right, then I can actually, in the Scout modeling environment, I can actually, based on this, and say I want to modify this shape. Maybe not this shape, maybe some of the shape that I see is not strong enough, and I want to strengthen this, right? So I can make my decision by choosing the shape, right? So I can double click, then you make the choice. And then if I do this modify, then I can just have the arrow of dragging it and making the change into my own flavor, right? So again, you know, all the patches, all the line segment, you can choose, and once you choose them, and you can say I want to do modify, and then you can drag and change the shape. So this is became like the scouting environment, we call it, right? And this is still captured in the history, right? So when you get out of the scouting environment, you are in the modeling environment. Of course, you can still get into drawing and so on and so forth. There are a lot of other applications available in this all-in-one. So let me get into the summary of the video of this Fusion 360, and then I get straight back into the generative design as a topic for today, right? So,
and list the Fusion 360 advisor community. The following 5 videos are the result of a passionate forum post, where our amazing users suggested that we put together videos pertaining to the philosophy behind Fusion 360. So here you go, guys. The Fusion 360 foundational concepts. In the first video, we'll start by discussing the importance of design intent, top-down versus bottom-up assembly design, before we move on to rule number 1. The next video will focus primarily on data management, a common place for new users to stumble stemming from Fusion's cloud-based data management. From there, we'll turn our attention to important options found in Fusion 360 preferences. Take a look at the different workspaces before spending the majority of the time looking at the timeline and browser. In the fourth video, we'll look at when you might consider using freeform versus parametric surfacing. Look at direct editing and parametric design before highlighting our newest design method. The last video covers bodies versus components and good old rule number 1 in the design of a simple bracket. Now, I know what you're thinking. I've got 30,000 hours in SOLIDWORKS. What are these videos going to teach me? Well, it's going to save you time. We've all made the transition to Fusion 360 from another CAD package. So have many others. These videos take the best of what we've learned in making the switch, and it will save you hours of potential frustration. And they will set you up for success with Fusion 360.
So my objective is to giving you the introduction. It's still like very beginning introductions, and then now getting into the details topics of the generative design, and then you have a lot of a success story, and then again details of modeling of how you actually get into generative design. So once you have the foundation, you have the knowledge, and then so how you're going to use it for your application, be it for architectural component like chair or tables, or certain fixtures that you want to replace, okay? So we call our generative design is real CAD, or true CAD. The reason is because in the past people call CAD, you still use a lot of your human brain together with the computer to execute. So it's a hybrid environment. It's not real true CAD. It's a human giving a lot of inputs. And now with the generative design, it's very much the AI. The percentage is maybe 10-20% of human interventions. The other 80% are all
CAD, computer-aided design. It's the cornerstone for how we design and build things. But how did it come into being? What are the historical milestones that got us to this point? And where is it going next? To find out, we're going all the way back to the beginning of time. No, we don't need to go back that far. Let's start in 1861. France. French chemist Alphonse Louis Poitevin discovers a process involving sunlight and a substance found in gum that allows original architectural drawings to be accurately reproduced. The process creates a negative copy, where black lines turn white and blank space turns blue, leaving users with a blue print.
Je le fais esprit.
Suddenly, designs can be easily replicated and distributed, allowing everyone to work from the same design without fear of errors in reproduction. It's no small coincidence that the second great industrial revolution starts just a few years later. In 1936, British codebreaker Alan Turing invents the Turing machine, which becomes the basis for the modern computer.
You're welcome.
Through the late 40s and early 50s, mainframe computing is introduced and goes commercial. And by 1955, transistors start replacing vacuum tubes, exponentially accelerating processing speed. Then, in 1961, renowned computer scientist Dr. Patrick J. Hanratty joins General Motors Research Laboratories and helps develop DAC, Design Automated by Computer. But it's Douglas T. Ross, computer scientist pioneer and father of computerized machining, that coins the term CAD.
Let's call it CAD. Okay, hooray!
Acronyms aside, to this day, it is Patrick Hanratty who's known as the father of CAD. In 1971, while Intel is busy introducing the microprocessor to the world, Hanratty introduces the CAD software known as Automated Drafting and Machinery, or ADAM for short. An estimated 90% of today's commercial drafting software can trace their roots back to ADAM. In 1977, CATIA, the first 3D CAD system, launches, running only on exclusive proprietary hardware. But by 1981, with the release of the IBM PC, desktop computing becomes affordable to the masses for the first time, and we see the beginning of the boom that would soon follow. On its heels, in 1982, John Walker founds Autodesk, and later that year introduces AutoCAD, the first significant CAD program for the PC, changing the world of design forever. Over the next decade, huge strides are made in CAD-based software. 3D modeling is introduced, opening the door to innovative design solutions, like BIM and digital prototyping.
Settle down, class.
Over the next few years, Autodesk introduces a steady stream of game-changing features, further embedding AutoCAD in the design industry as an indispensable tool of the trade.
Class dismissed.
In fact, in 2007, Autodesk ships their 8 millionth copy of AutoCAD. From 2010 on, advances continue to be made, including a web-based mobile version of AutoCAD that frees designers to work from anywhere, and Autodesk Recap, technology that allows users to create designs using real-world data captured from photos and laser scans. This is the evolution of CAD, from blueprint to desktop to cloud. Today, we see the Internet of Things continue to provide data to build smarter cities and better products. And eventually, generative design tools will use the infinite computing power of the cloud to change the very way we work, as our computers will begin to have opinions of their own and even begin to create designs for us. We'll have reached the point where the term computer-aided design truly means what it says. The tools of design have come a long way, but the story of CAD is really just beginning.
So it's education, because it goes back a lot of history from very beginnings, right? And as I tried to explain early on, the way it's trying to explain the true CAD is about more using the computer or AI to do the calculations rather than humans, right? So as this example of the chair in these pictures here, so you can have multiple outcomes, right, to solve a design problem. And so for human, it's just making the decisions out of so many choices, which would be the best, and then therefore it's enabling you to have more thinkings in the outcomes for improving in the aspect of manufacturing capability, improving in the aspect of strength and so on and so forth, right? So this is again a little bit of a history converging it's happened in the last few years, right? In making it what is possible. In Autodesk, as a company from the divisions that I'm working with, we have in the terms here called shop floor of fabricates, right? Fabrication is actually related more towards the computer-aided manufacturing. So you have machine and all these things, right? And today with the advance of additive manufacturing, so then you have a new way of making things, right? So the generative design is actually as new definitions, right? Because it's define the functions and the process itself, and then eventually it's not just using so much of human power, but all this is consolidating and converging it to become a much more simpler route. Okay. Now from these pictures of the Earth, right? The route of getting from point A to point B, you have many choices, right? You can be by airplane, by ships, or by bike or human. So then this is similar like in generative design. When the computer is actually giving you the calculation, it's actually giving you an optimization, right? Now there's a comparison of, I'm just going to give a chart of comparison of this because a lot of people still have misconception or understanding of topology, optimizations, and generative design. So I think this slide have this towards the end there.